Okay, so this is Computer Science 250. This is your first real programming class. The prerequisite for this class was CSC 200, which was our introduction to computer programming. We used that tool called Game Salad in there. I will assume everybody in here has had that. I know there's a couple of you who do not have that prerequisite. That's kind of on you. I do spend the first week or so of this class reviewing a lot of the stuff from there, so I guess I don't think you're screwed if you didn't have that class, but you do need to take it at some point. But I do make the assumption some of the problem-solving stuff you've seen before. Okay, blah, blah, blah. You know when the class meets. Grading. Homework assignments, 45% of your grade. Quizzes, they will be pop quizzes. I'll give them whenever I feel like it. Usually it's when attendance is crappy. So if I see a bunch of people missing, I usually give a quiz. Sometimes I just give it because I feel like being mean. Sometimes I give it because I think it's funny. I always find that interesting. You know, like the most stressful time of the semester for students is like midterms and finals, right? I mean, that's kind of like the week off for profs. It's like, okay, I just got to sit in here and I have to play video games while they're like sweating over a test. I kind of get enjoyment out of that, is what I'm saying. So, yeah, so pop quizzes when I feel like it. Midterm and final, each 20% of your grade. Like I say in most of my classes, I don't believe that one bad day should really screw your grade. So if you struggle on the midterm or something like that, we can sit down, we can talk about it and come up with some sort of way. Maybe I count your final twice or something like that. You know, but at least it gives you a wake-up call as to where you're sitting in the class. Okay? So big exams, 40% of your grade, one way or another. Okay. Normal grading scale, 90, 80, 70, 60. I do reserve the right to curve, but don't count on it. Usually I'm able to stick to that. So questions. This is already up on Angel. You can go and read the details, the small print, and all that other stuff. Questions about that? Okay. Here, I'll throw on the first slide here. You can also read it on my door. But, so, I'm Mike Littman. A lot of you know me. You can call me Mike. You can call me Dr. Littman. You can call me Yo Fatty. I don't care. I am not a formal person. So, yeah, whatever. Contact information. You can email me at michael.littman@cuw.edu, or you can text me at 262-353-6205. You can try calling, but I probably will not pick up. I pick up for two people, my wife and my mom. And actually, I'm halfway lying about my mom. I've taught her to text me. My wife, she knows to only call when it's an emergency. Otherwise, it's a text. But texts will probably get you your quickest reply, followed up by email. You can text me whenever you want. I usually go to bed like 11 or 12 or something. So you might, if you text me at 3 in the morning, you might not get a reply till 6 a.m. the next morning. But feel free to, if you have questions in your homework or something, to text me whenever you want. Office hours are posted on my door. New office is now right next door to here. If you go out past the bathroom, and then you'll see the entrance to the office. I think I'm in there Monday, Wednesday, Friday, 3 to 5 p.m., and then Tuesday, Thursday, 7:30 to 9:30, kind of butting up against chapel. Usually I'm just in there watching movies or something, so feel free to drop by or whatever. Okay, so without further ado, we ready to start programming or something? I thought you were taking this online. What class are you taking online?
The other one.
Oh, 300. That's right. I'd already worked myself up. I wasn't gonna have to deal with you. Oh, both of you. You're taking it online too? Oh, okay. So yeah. So is. I'm talking. Well, I guess I'm talking to both of you now. Kill two birds with one stone, right? Is that biblical? I think so.
It's like 2 in the hand, it's 1 in the book.
I don't think that's right. Okay, so we're going to spend a little time reviewing some stuff from last semester. So you're going to see some repeat slides here, and I think we're all going to be shocked how little you remember from last semester because outside of a few of you, I'm sure everybody spent their entire summer break doing computer science programming. Most of you wrote your own video game, right? Did anybody actually work with Game Salad or anything like that over break?
I figured out how to integrate an AT&T cell phone.
Into what? You integrated it into what?
Into their system through UMTS, GSM, and LTE.
Okay, into whose system? Okay, so you integrated antennas into their system.
New antennas and radios.
Okay. Was that your job?
Yeah. 300 feet in the air.
Okay, or was this kind of like a hobbyist free internet type thing where you climb the side of a cell tower, ran a couple of cables?
Well, I can do that now.
Yeah, makes sense. Okay, so how do human beings solve problems? This is a review slide from last semester. It's probably on a couple of your different exams last semester. How do human beings solve problems? 3 different things. Go ahead.
Memory, repetition, and asking questions.
Repetition, that's spelled right? Close enough. All right, so the way human beings solve problems, we were to make this generic. We use our memory, able to remember things. We ask a lot of questions, and we do repetition. Rinse, lather, repeat type stuff. Now, why is computer programming hard? Talked about this a little last semester. Related to this. How many of you consider yourself to be good problem solvers? 4.5, 6.5 of you? 9? Nice. Some of you struggle with the problem-solving aspect of raising your hand. Okay. Human beings are really, really, really good problem solvers. We're so good at solving problems, in fact, that we suck at telling other people how to solve problems. Because we take so many steps in the middle for granted, right? The example I used last semester was, how many of you, when you were coming to class today, bumped into a wall your way to class? A couple of you may have. There's always one smart ass that says something, right? But generally, we can navigate the halls of this university, even with other people walking by, even while texting, and not bump into walls. Now, how many of you, as you were walking to class, even thought about, well, I got to avoid these walls today? Didn't even cross your mind, right? But you still avoided them. How? How'd you miss those walls? How many questions do you think you ask per second while you're walking down the hall, texting, and you have people flying by you, going both directions? You're constantly adjusting, putting weight on one foot versus the other, making little tiny micro adjustments. Am I going to hit something? 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 Over and over and over and over again. And you do it so often, you've been doing it for so long, you have forgotten that you do it. You don't even recognize it. That becomes a problem for computer programmers because we need to now tell a computer individual little baby step instructions, every little piece that it needs to do to solve a problem. So if we were trying to teach a computer, let's take one of those, did you guys do in the 175 class anything with the Lego bot things? Okay, so let's say you were trying to train the Lego guy to go around campus. So the Lego bot thing has like a small computer language, right? Small programming language associated with it. And you're going to train it so that it doesn't bump into walls. Well, you're going to use some of the sensors. You're going to constantly have it check for things in its way and make adjustments, right? If I keep going forward, I'm going to hit something. So don't go forward anymore. Let's turn left a little. Then go forward again, over and over and over again. And then what does our Lego bot look like? It looks like, it's kind of all stutter stepping down the hallway, but hey, it's avoiding stuff, right? Funny story, you should see how Roombas react when you have 3 cats coming from different directions after them. Someone's got to work on that algorithm.
I'm trying to, I want to see this.
What's up?
You make a video of
I
this.
should make a video of it. We need a new Roomba now. Your cats also will attack Roomba. And I have big cats.
There's got to be a YouTube channel for that.
Well, I've seen some channel that shows like a couple of dogs sitting there, and there's some music playing in the background, and all of a sudden Roomba comes across, and there's another dog just sitting on the Roomba, just chilling. So, but yeah, so Roomba we can think about it as maybe a little more high-tech Lego bot, right? And it tries to not bump into walls, and it kind of figures out and maps your living room and gets around the couches and all that stuff. But when it has moving targets like cats running around it, attacking it, and things like that, Roomba starts, scattering, sidestepping and things like that. So we are doing that as human beings all the time, even though we're not aware of it. Okay? So one of the challenges we have to overcome to become good problem solvers with a computer programming language is training ourselves to become aware how we're solving these problems. At the very least, the problems we're trying to teach a computer to do. Okay, so programming languages, just bounce back here real quick. A computer programming language, the language we're going to use in here is a language called Java. Okay, first thing I'll say, let me say this first. Every single programming language attempts to emulate these 3 things in some way. So when a senior comes up to me and says, I'm not very good at Java, but I'm really more of a .NET kind of guy. I kind of laugh inside, and then I really laugh outwardly at them. Programming is programming. Language does not matter. Every single programming language is emulating the same crap. Okay? So if you can figure out how to deal with memory, how to ask questions, and how to repeat stuff in a programming language, you can solve, let's call it 80% of all problems. Then it's just a matter of learning about the extra little, built-in functions in that language that might make certain things easier. But we're going to learn to write our own functions, so even if we didn't know about the built-in function, we could have just written it ourselves. We didn't take advantage of the convenience. Okay? So all programming languages are the same. In fact, most of the modern programming languages are actually from the same core language. We talked about this last semester. I'll show another thing here in a second. But we kind of talk about our modern programming languages. Way back in the beginning, we had a language called C. Okay, the C programming language was created, I don't know when it was made, late 60s, something like that, specifically for writing operating systems. And if you're in the operating systems class, you'll learn what an operating system is. So off of C, they decided, hey, we need an object-oriented version of C. We'll talk about this in a few minutes. I'll remind you of those things. I know we talked about it last semester. And this was Microsoft's side of things. And of course, Apple, always agreeing with Microsoft, said no. We're going to have our own language called Objective-C. So C++ was an object-oriented version of C. Objective-C was an object-oriented version of C. They have a lot of similarities, but then they took some deviations, and they don't quite look identical. Off of C++, we got Java, which is the language we're going to use in here. We also got the .NET languages, specifically I'll list C#. We'll call this our most powerful .NET language. Other .NET languages are Visual Basic. And if anybody ever comes up to you and says, "Oh yeah, I'm a software developer," and then they say, "Oh, well, what do you write?" "Oh, I write Visual Basic programs." You laugh at them. You should laugh at them. Visual Basic is actually kind of an entertaining. I can't tell if it was it's a hard debate as to whether it was a good thing for the industry or a bad thing. Visual Basic was created in the probably late 90s, early 2000s as a tool as more and more companies started having custom software being built internally. A lot of these companies didn't have the competence inside the company to write the software. You know, these people were business folks or analysts or something like they weren't computer programmers, they weren't computer scientists. So Microsoft created a tool that allowed non-programmers to write business applications, rapid application development, RAD. And that's what Visual Basic, that's what the tool was for. Well, all of a sudden, Visual Basic started being leveraged for things that it was never intended for. You know, you had people writing games and full-fledged business applications that were being sold in, you know, Best Buy and stuff using Visual Basic. Now, Visual Basic breaks like so many computer programming rules, it's not even funny. The example I always use is that you can, and this will make more sense later when we deal with typecasting, but you can like turn an integer into an ice cream cone in Visual Basic and then do math with it, and it will give you an answer. So now if I told you to add the number 7 to an ice cream cone, what answer would you expect? It doesn't make any sense, right? Visual Basic will give you an answer. I don't know what the answer is, but it will not throw an error. It determines what it thinks an ice cream cone's value is, adds it to 5, spits out the answer. That's problematic. Okay, programming languages need to be unambiguous. So just getting back to what we were saying before about how we solve problems, in order to tell a computer how to solve problems how to solve a specific problem using a programming language, we have to break the steps down to that solution into itty bitty little tiny baby steps and explain each little piece. Okay, and if we start doing math with ice cream cones, somebody's getting confused. At the very least, the language should scream at us, right? Visual Basic does not. It's a dumb language. Don't write stuff in it. Because you will open yourself up to ridicule. So anyways, we're going to call the .NET language that people take seriously C#. Secondarily, the other language that people would take seriously is ASP.NET, which is their web programming language. It's kind of the competitor with PHP if you've ever done some web programming. Okay, so anyways, this is kind of our lineage here. Java, C# look nearly identical. You can take a Java program, try to compile it in C#, and it would probably almost work. And I'll actually show you something along those lines today, comparing the two of them when I show you how to write your first Hello World program in Java. Now again, Apple decided, hey, we don't really want to follow suit here, so we're going to come out with Objective-C 2.0 to kind of keep up with these guys. So these guys tried to fix some problems from C++, and we'll talk about some of those throughout the semester, some of the issues that arose from those. But in any case, Apple decided to go this route. Now, funny little story in the middle, Apple, see, this is really Microsoft's baby here, C#. Java's not. Java was created from a company called Sun Microsystems, now owned by Oracle, database people, right? So Apple really didn't have any reason to hate Java. In fact, some of the Steve Jobs, the founder of Apple, and the guy who, Larry Ellison, Ellison, founder of Oracle. That's the right name, right? Who's the guy who's Virgin Atlantic? That's not Ellison. I think I'm right here. Okay, Larry Ellison, founder of Oracle. We're like best friends. So this kind of made sense. Apple decided, hey, we're going to go ahead and adopt Java as our main language. So now you had Java versus C#. That turned out to be a really, really, really bad idea. We're going to talk here in a few minutes about some of the weaknesses with Java. Java's a great language. Tons and tons and tons and tons of benefits. But for high performance applications, it's a very poor choice. Okay, so here, I'll even just talk about that now. So Java. What can you tell me about Java? What do you know? What are the buzzwords, the things about Java that you can tell me? Who? Free. Java is free. True. So is C#. Cross-platform. So it's platform independent. So you write your program once, it'll run on any computer that has the Java virtual machine. Go ahead.
Didn't we already say it was object-oriented?
It is object-oriented. So just quickly, let me pause there and go back to, let me go right after this slide. Just as another quick reminder, remember all those slides from last semester? You know, there are 3 kinds of programming languages, there are 2 kinds of programming languages, blah, blah, blah. So we have 3 kinds of programming languages. We have procedural, object-oriented, and functional, which we're going to pretend doesn't exist in here. When you take the programming language theory class with me, we actually use a functional language in there. That's, what class is that? 460 or something like that? I don't know. It's probably our hardest class. You'll have a blast. Let's see. So 3 kinds of programming languages: procedural, object-oriented, and functional. Now, a good way to kind of talk about these, I usually use the example of a telephone. The procedural version of a telephone, and by the way, C, the C programming language, is a procedural language. If we were representing a telephone over here, the procedural version of that would just be a pile of wires that happen to just all connect with each other in the special way that allows it to actually function as a telephone, even though we don't look at it and think, oh, that's a phone. We look at it and say that's a pile of wires. Okay? That would be the procedural representation of a phone. The object-oriented representation, of which C++, C#, Java, Objective-C, Objective-C 2.0, these are all object-oriented languages. It's kind of our next level of evolution for our programming languages. The objective, or the object-oriented version of a phone would actually look like a phone. So this is a phone, correct? Now, there's crap inside of this that makes it do its stuff, correct? Now, most of us don't know what all that stuff is. Or we've seen it maybe on some disassembly, video on YouTube or something like that. But we know there's like chips and crap in here, right? They're all soldered together in some special way. And then each of those pieces is a bunch of wires and stuff like that at some crazy level. So we can look at it and say, oh, well, that's a phone. If we needed to get to the details, we can. We can rip it open and get in there and start messing with stuff. But on the surface, it's the most convenient to work with this as a phone. Now, this phone has a bunch of details inside of it that we will rarely, if ever, need to deal with. But we also have public interfaces. We have this home button. Home button allows me to turn the screen on. So does this other button up here. So we have a couple of So Nick decided to send me a text of the happy goat as I'm like waving this up in the... So anyways, we have our public interfaces, the buttons that we can click on the phone to make it do the stuff that we normally interact with the phone, normally do with the phone. So those are the things that an object-oriented language does. It exposes the public interfaces of the object and then hides the details from us unless we need to get to it. So we can say object-oriented languages are better. I think that's relatively fair to say. Realistically, we're going to use Java for the first at least half of this semester as a procedural language, even though it's an object-oriented language. We're not going to take advantage of some of the object-oriented features of it until the second half of the semester. Okay, so we'll be procedural programmers for the first half or so. Okay. There are 2 kinds of programming languages. Strongly typed loosely typed. Okay, and these things are going to tie into memory that we talk about here in a few minutes. Strongly typed means that we have to define what kinds of values we're going to remember in the language. Loosely typed says we can just remember stuff. We don't need to give a definition of what kind of value it is. So our modern language, like Java, is high level. What's a high level language? Well, there are three kinds of programming languages. Machine language, low level, high level. Those are our three kinds of programming languages. Machine language, what our computers understand, zeros and ones. Okay? Now, none of us want to talk to computers that way. A little 2-button keyboard, just tapping it out. Okay? A low-level language is actually a programming language, but it has a one-to-one relationship with the CPU. So when we think about our processor, our Intel processor inside of our computer, that guy is the brains of our computer. It has a whole list of magic tricks it knows how to accomplish. Okay? A low-level language tells the processor, do this magic trick followed by this magic trick followed by this magic trick, and poof, something awesome happens. Okay? But even the simplest programs in a low-level language can be very, very lengthy. Because those magic tricks that the CPU knows how to do are extremely generic. All right? And what you do is you put together a couple of million of those magic tricks in a row, and all of a sudden, hello world pops up on the screen. All right, so low-level languages are often tedious to work with. We rarely, but sometimes, do write in low-level languages. I'll talk about that here in a second, just as a quick review. I'll actually ask as a question first. High-level languages are what we're dealing with most of the time. Java is a high-level language. That is, every line of code we write has a many-to-one relationship, or one-to-many relationship with the CPU. So every line of code we write in Java translates into a bunch of magic tricks the CPU knows how to do. Okay, so it's like a power tool. It allows us to write our logic in a human-like language, and then we run it through something called the compiler, and the compiler translates it into a low-level language. Now, having said that, there are two kinds of programming languages. We have interpreted languages, and we have compiled languages. A compiled language, like Java, takes our source code, our Java code, runs it through a tool called a compiler. And what the compiler does is it translates our high-level language into a low-level language prior to us running the program. An interpreted language does the conversion. We can still say it converts from high level to low level. It really is just running in real time, but it does the conversion while the program's running. Okay? Now, Java is a compiled language, but there are aspects of Java that act like an interpreted language. I'll talk about that here in a few minutes. That's related to this whole platform independent piece here. So Java is a high-level, object-oriented, strongly typed, high-level, object-oriented, strongly typed, compiled, there are two kinds of programming languages. Domain-specific, okay, and general purpose. Domain-specific would be a language like HTML, okay, which is made for, hypertext markup language for making web pages, right? Very small language. You can learn most of HTML in a weekend. It is a language very, very, very specific to the domain of making web pages look pretty. Okay? General purpose languages like Java have tools built into them that allows you to solve a wide array of general problems. All right? So one might extrapolate that general purpose languages are typically much larger than domain specific languages. And Java is general purpose. Okay. Now, the platform independence nature of Java is probably its best feature and worst feature. Kind of an interesting dichotomy there.